Hi, my name is Lydia Toombs and I'm in Lab Section 6, and today I will be showing you multiple calculations based on the concentration of citric acid in lemon juice. In this experiment, a neutralization reaction occurred. Citric acid, which is C3H5OCOOH3, that is aqueous, reacted with sodium hydroxide, which is 3NaOH, and that is also aqueous. Those two substances reacted to form sodium citrate and water. Sodium citrate is NaC3H5OCOO3, and then there's 3 water, which is H2O, and that is liquid. And the sodium citrate is aqueous. In order to find the concentration of citric acid in the titrated sample, stoichiometry must be used. To find the concentration of the first exact titration, the experimental volume of NaOH will be used. So, the concentration of trial number 1 can be calculated by multiplying 17.65 milliliters of NaOH. So first, you're going to need to convert that to liters. So that is 1 liter per 1,000 milliliters. And then you multiply that by the molarity, which is 0.0813 moles per 1 liter. And finally, you want to multiply that by the ratio of 1 mole of Na3C5OCOO3 over 3 moles of NaOH. So that concentration value of 0.004783 moles of Na3C5OCOO3. So you want to take those moles and divide that by the volume, which was 0.002 liters. So if you divide that by 0.002 liters, you will get the molarity, which equals 0.2392, and that is the molarity. Next, we're going to calculate the average citric acid concentration from the 3 exact titrations that were calculated. So the concentration calculations above, and the concentrations of the second and third titrations will be added together and divided by 3 to find the average concentration. So first we had the concentration of 0.2392. That was from the first exact titration. And then the calculations of the second and third were 0.2408 and 0.2430. So those 3 values are going to be divided by 3, and then that will be the average concentration, which is 0.2410. And that is the average concentration of Na3C3H5OCOO3. Finally, the average pH of the lemon juice sample before the titration and after the titration will be calculated. The average before the titration was 2.66. So first, to get this value, you add all the values of the pH before the titration and divide by 3. So you're going to have 2.72 plus 2.61 and 2.65 divided by 3. And these are the 3 pHs before the titration. And you get the value of 2.66. You do the same exact thing to do the pH average after the titration. So after, the values were 9.07 plus 9.10 and 9.02. You divide by 3, and you get the value of 9.006. The pH is calculated by taking the negative base 10 log of the hydronium ion concentration. The lower the number of the more acidic the concentration is, and vice versa. The neutralization reaction changes the pH by diluting the solution to make it more neutral or less acidic. All the information I got for this report is from the Chemistry 110N Foundations of Chemistry Laboratory Manual, written by Dr. Booth, Dr. Jean, Dr. Santoro, Dr. Salatis, and Dr. Schaub.